All right, in Chapter 8, we are going to be solving equations. So we're going to be taking what we've learned about algebraic expressions and how to simplify them and manipulate them and use different terms in them to apply those to equations and solving different types of equations. And we're going to start solving equations with rational coefficients. And remember, the coefficient is the number that's being multiplied by the variable. So we're going to be solving equations that contain fractions and decimals as coefficients. So obviously, we're going to be looking for something called a solution, and that's the value for the variable that makes the equation true. And we're going to use inverse operations, and those are operations that undo each other, or in other words, opposite operations. Like the opposite of addition is subtraction, and the opposite of multiplication is division. The opposite of powers are roots, but we won't be doing any roots in this chapter. But just to give you that idea of what we mean by inverse operations, and equivalent equations, equations that have the same solution. So let's jump in here and take a look at this expression, or this equation, a times b equals c. Well, what else is true about these values a, b, and c? If a times b is equal to c, what else is true about the quantities a, b, and c? So in other words, what's true about this fact family? Maybe you've heard of fact families before. We're going to be using these facts to help us solve equations with unknown values. Well, a couple of things that we do know is that if a times b is equal to c, then a is equal to c divided by b. Isn't that true? If a times b equals c, then a is equal to c divided by b, and also b is equal to c divided by a. Okay, these facts are true. Now, if you want to look at just a simple example, let's say a is 2, and b is 5, that means c is 10. Well, if 2 times 5 equals 10, then 2 must be equal to 10 divided by 5. That's this statement right here. And likewise, 5 must be equal to 10 divided by 2. That's that statement right there. Okay, so just to give you an actual example, a concrete example of what we mean by these fact families with multiplication and division, we're going to be using these facts to help us solve equations. So to solve equations, we're going to use the inverse operations to find the value of the variable. So in this example, we have 4.2x equals negative 52.5. That means 4.2 times x equals negative 52.5. So we're going to use the inverse operation, or the opposite operation of multiplication. Since this is multiplication right here, we're going to use division to write an equivalent equation. Now, this equation right here is equivalent because x is the same value in both of these using the fact families we just learned on the last screen. So if 4.2 times x is equal to negative 52.5, then x must be equal to negative 52.5 divided by 4.2. And that we can calculate, and we can find the value of x. X has to be negative 12.5. And we can always check that by putting that value back in the original equation. 4.2 times negative 12.5 is equal to negative 52.5, so we know that the value of x has to be negative 12.5. And that's really the basic concept behind solving equations with rational coefficients. So let's take a look at several examples here. The first one, negative 19.6 is equal to 5.6 times x. Well, if that statement is true, then another statement in that fact family using the inverse operation, negative 19.6 divided by 5.6 will equal x. And if you calculate that, you get negative 3.5 is x, and there's our solution. Okay, pretty easy to find solutions to these, what we call one-step equations. And of course, we can always put that value back up in here for x. 5.6 times negative 3.5 is negative 19.6, so I know that that solution checks out and I got the right answer. Next one, negative 20.9 times y equals negative 50.8. Again, if this is true, then y is equal to negative 250.8 divided by negative 20.9. Now make sure that you're dividing by the same thing that y was being multiplied by. A lot of students will mix that up and divide backwards. If we're multiplying y by negative 20.9, we have to divide by negative 20.9 to find the solution. And then when you do this, you get y is equal to 12. And then, of course, if you check your solutions by plugging it back into the original, you'll always know if you got it right or if you accidentally divided backwards. Next one, negative 13.6 times A is equal to 217.6, sorry. So A must be equal to 217.6 divided by negative 13.6. And then that gives me a value of A is equal to negative 16. And again, if I plug that back in and check here, negative 13.6 times 16 is a positive 217.6. And then the last one here on this screen, 323.4 is equal to negative 13.2 times Z. So I'm going to take 323.4 divided by negative, sorry, that should be negative 13.2. That will tell me what Z is, and that is negative 24.5 is Z, and we have solved that equation as well. So there was a bunch of examples with decimals as our coefficients. Again, those are rational numbers. Let's take a look at some where we have fractions as our coefficients. So 7 is equal to negative 1/2 times x. Same concept here. I'm going to divide by negative 1/2. I'm going to take 7 divided by negative 1/2 to tell me what x is. That's an equivalent equation in that fact family, and that is negative 14 is x. And again, I can always check that. Negative 1/2 times negative 14 is a positive 7. So I know I got the correct solution there. Next one, 6/7 times m equals negative 3/14. So m is going to equal negative 3/14 divided by 6/7. And that gives me a value of negative 1/4 for m. And the next one, negative 9 equals 1/3 times n. Negative 9 divided by 1/3 will tell me what n is, and that's negative 27 equals n. Again, if you're not sure, plug that right back in there and check that. 1/3 times negative 27 is negative 9. And the last one, negative 1/4 divided by 2/7 will tell me what the value of y is, and when you evaluate that, you get negative 7/8 is equal to y. So examples of decimal coefficients and fraction coefficients in our one-step equations. One last one here just to give you an example of something you might run into. Here we have an equation that has two terms in it that have the variable. We're going to refer back to what we learned last chapter on simplifying this algebraic expression. We're going to simplify the left-hand side of this equation before we try to solve it. 5p minus 2p, those are like terms. That gives me 3p equals 12, or 3 times p equals 12. And that one might be mental math, but just to make sure, the equivalent equation here is p is equal to 12 divided by 3, which is 4, and that is our solution since 3 times 4 is 12, or 5 times 4 is 20, and 2 times 4 is 8, and 20 minus 8 is also 12. So that works out any way you slice it. So solving equations with rational coefficients, we're using the inverse operation, which is, in this case, division, since our coefficients are using multiplication.